Okay, we are back, and we are now doing lesson 9.4. And I want to review something that you've learned in your previous math classes along the way, because we're going to be using that in this lesson. Okay? Um, when we multiply fractions, we remember that we multiply numerator with numerator, that is, the top number of the fraction with the top number of the other fraction, and then multiply denominator with denominator, and that is the bottom number of one fraction with the bottom number of another fraction. So let's just look at an example. Okay, two fractions being multiplied. We simply multiply numerator with numerator, our top numbers, so 4 times 6, and denominator with denominator, our bottom numbers, 7 times 5. And this would be our answer right here, and that is not reducible. Okay, algebraically, the way we would say this is A over B times x over y is equal to ax over by. Okay, and you learned that years ago in your math courses, how to multiply fractions. Okay, I just wanted to have that fresh in our minds as we look at our next rule, and it is called the power of a quotient rule. Power of a quotient rule. Okay, well, quotient, you know, deals with division. So this rule pertains with pertains to division and applying a power to a division problem. Okay, now so far the rules that we looked at had to do with multiplication of powers. But remember what our rule for division is, or our definition. Remember this from the past, that we say that division is multiplication by the reciprocal. So we can actually define division in terms of multiplication. Therefore, it should not surprise you that the rules that we have for working with exponents deal not only with multiplication, but with division as well. Those two operations are related, okay? So here's our first rule when dealing with a division problem that is raised to a particular power. The power of a quotient rule looks like this. X divided by y raised to the a, raised to some power, is equal to x raised to the a divided by y raised to the a. So basically, we can say that our exponent distributes to both numerator and denominator. Do you see that? All right, well, let's watch this happen, okay? And let's look at a real-life example. All right, if we have the fraction 2/3, okay, that's our x and our y, our 2 and our 3, and we're going to raise it to the 5th power. So this is the type of problem that we're talking about. When we say power of a quotient, remember quotient means division. Well, a fraction is division. That line between the 2 and 3 is a division bar. So you can see that this rule is properly named. We are dealing with division here, and we do have a quotient. All right, well, before applying this rule, let's just think about what 2/3 raised to the 5th means. Well, an exponent tells us how many times our base is being used as a factor. And what we're learning here, or seeing here, is that our base, 2/3, is being used as a factor 5 times. So let's work it out that way first. 2/3 times 2/3 times 2/3 times 2/3 times 2/3. 1, 2, 3, 4, 5. There they are. Okay, well, let's take a look at this. 2 times 2 times 2 times 2 times 2. What we have is repeat multiplication in our numerator. Our base, 2, is being used as a factor 5 times. Look in the denominator. We have 3 times 3 times 3 times 3 times 3. Well, to show repeat multiplication, the number that's repeatedly multiplied, that's our 3, is our base, and the number of times it's being used as a factor is our exponent. So do you see here that 2/3 quantity raised to the 5th equals 2 to the 5th divided by 3 to the 5th, okay? Now, we worked it out the long way here. We could realize that this exponent immediately can apply to both numerator and denominator. It sort of distributes to both numerator and denominator. We don't have to go through this long process to prove it to ourselves, but we have proven it. We see that this is a true rule. This is true. Okay, so let's just take a look at a couple other examples here. We have, here's an easy one. Oops. Okay, x divided by y raised to the 7th. All right, well, okay, use our power of a quotient rule. We're going to distribute that exponent of 7 to both numerator and denominator. So we have x to the 7th divided by y to the 7th. There is our answer. Okay, now, those that we've looked at thus far have been fairly easy. I want to look at another one that is a little more complicated. Okay, there's more involved in it. Let me see if I can find the top of my paper. There it is. Okay, here we have x cubed y divided by z to the 4th, all raised to the 2nd power, or we could say squared. Okay, well, we need to realize a couple different things. And that is that, first of all, this exponent distributes to both numerator and denominator. So I'm going to do that first. I'm going to write my numerator and put the exponent of 2 on the outside. And I'm going to write my denominator and put the exponent of 2 on the outside. All right. Now, since we have applied our power of a quotient rule, we now need to apply the power of a power and power of a product rule. Okay, let's work with numerator and denominator individually now. Well, we have an exponent on the outside of our parentheses, so we're going to be dealing with power of a power here. We're going to distribute that exponent to every factor inside parentheses. Okay, so we have x cubed squared. We're distributing that exponent of 2 to every factor inside the parentheses. Y squared. Let's do the same thing down here. Well, it already is in that form, so I'm just going to rewrite it. Okay, now is when we're going to use the power of a power rule. We have a power and we're raising it to a power. This is what we learned in our last video, okay? We're going to multiply our exponents, all right? So x cubed quantity squared would be x to the 3 times 2, and then we have y squared. Down here, we have the same situation as we had up at the top with our x variable, okay? We're raising a power by a power. We multiply our exponents, okay? All right, and finally we can simplify. X raised to the 3 times 2 is x to the 6th, y squared. Z raised to the 4 times 2 is z to the 8th. That is our solution right there. Okay, so we put several of our rules into practice. We put the power of a quotient rule into practice by distributing the outside exponent to both numerator and denominator, and that's what we did here. We used a power of a power rule when we had to, well, no, first of all, we used the power of a product rule by distributing the outside exponent to every factor inside the parentheses, and that's what we've done here, okay? And then we use the power of a quotient rule. I'm sorry, the power of a power rule, where we are multiplying exponents right here. Okay, so it did take working out several of the rules, but that's okay. If we know them, we can work with them, and that's fine. I'll be back with another video.